Welcome back to the deep dive. Our mission, as always, is pretty straightforward. Take a big pile of complex info, boil it down, and give you the core knowledge you need.
That's right. And today, we're really diving into something fundamental, corporate survival in this modern age.
Yeah, we're looking specifically at the ideas of Thomas Siebel. You probably know him, founder of C3.ai and way back Siebel Systems. He basically invented the CRM market.
Exactly. And his 40 years in tech, I mean, he's seen it all. Relational databases, the whole internet boom, now AI, IoT. It gives his perspective, well, a lot of weight.
And that perspective is pretty stark. His main idea, especially from his book Digital Transformation, is that four huge tech forces are converging: cloud, big data, AI, and IoT.
Right.
And he says this convergence isn't just causing disruption, it's causing actual mass extinction events across industries, like wiping companies out.
It is dramatic language, but that's
Yeah.
the core idea. It's an environmental shock. We need to get our heads around the why behind this corporate collapse.
And more importantly, how organizations, maybe your organization, maybe your own career, can actually navigate this, survive, and, even thrive.
It's really a framework for understanding why everything feels like it's moving so incredibly fast right now.
Okay, so where does Siebel start? To understand the speed, he actually looks back quite a way.
He does. He traces the intellectual spark back to a 1973 book by Daniel Bell, The Coming Post-Industrial Society.
1973, wow. What was Bell saying back then? Computers were like room-sized things.
Exactly. That's what's amazing. Bell predicted that knowledge and data would become the critical resource, overtaking labor or capital. He saw this new class of professional, knowledge-based elites rising.
And he predicted this when the most advanced chip was the Intel 4004. That's incredible foresight.
It really is. Bell talked about how pre-industrial society was humanity versus nature. Industrial society was humanity versus machines, factories.
Right, fabricated nature.
But this post-industrial society, which is where we are now, he said it's a game between people. And it's powered entirely by knowledge, by data.
Okay, so that sets the stage. Knowledge is the key resource. How does that connect to the speed and the violence of the change Siebel describes?
Well, to explain that sheer speed and intensity, Siebel grabs a biological metaphor. Not just disruption, but something much more dramatic. Punctuated equilibrium?
Punctuated equilibrium, I know that from biology. Stephen Jay Gould's right. It's not the slow, gradual Darwinian evolution we usually think of.
Exactly the opposite. Gould's theory suggests evolution happens in bursts. So you get long periods of stability, things stay pretty much the same. That's stasis.
Okay.
And then, boom, short, rapid bursts of intense evolutionary change, usually kicked off by some big environmental shift.
Huh. So why use that biological theory for business? Isn't it just, faster innovation or disruption? Why equilibrium and punctuation?
Because, Siebel argues, disruption often means one product beats another, like a better mousetrap. Extinction, in this biological sense, means the whole system, the fundamental way the organism or the company operates, just fails because the environment changed too drastically.
Okay, I see the distinction.
The classic example is the Cambrian explosion, about 541 million years ago. Life just exploded in diversity over maybe 20, 25 million years. Basically set up all the major animal body plans we still see today.
A burst of creation after some massive environmental change.
Precisely. And Siebel says that's what's happening now in the corporate world. We're in one of those punctuated moments.
And the evidence for this corporate extinction, it's already pretty sobering.
It really is. Look at the Fortune 500. Since the year 2000, just over 2 decades, 52% of those companies are gone. Acquired, merged, bankrupt. Vanished from the list.
Half of the biggest companies on Earth gone in 20 years. But couldn't some of that just be, normal business cycles? Mergers happen?
Some, maybe. But the scale and the speed. Siebel argues it points to something more fundamental, and the forecasts are even starker. Estimates suggest 40% of companies operating today won't be around in 10 years.
40% in the next decade. Okay, that doesn't sound like gradual change. That sounds like the technological environment is shifting incredibly fast.
That's the trigger. Those 4 converging technologies we mentioned, cloud, big data, AI, and IoT, they are the environmental event.
Right, let's break those down. Driver number 1, elastic cloud computing. What's the core idea there?
Think of the cloud as the new utility, like electricity, but for computing power and storage. Amazon, Google, Microsoft. They offer basically unlimited, scalable resources.
And it's cheap, right? Compared to the old way.
Dramatically cheaper. It completely flips the old model where companies had to sink millions, sometimes hundreds of millions, into building and maintaining their own giant data centers that just got old and slow.
So the cloud provides the infinite cheap power. What fuel runs on that power grid?
That brings us to big data, the second vector. And Siebel uses another really intense biological analogy here, the oxygen revolution.
The oxygen revolution, data as oxygen. But wasn't oxygen originally like poisonous to early life?
Exactly. That's the power of the analogy. Around 2.45 billion years ago, these little cyanobacteria started pumping out oxygen. For almost everything else alive then, oxygen was toxic. It caused a mass extinction.
So most life died off.
The vast majority, yes. But the organisms that figured out how to use oxygen, how to breathe it, they survived and thrived. They unlocked energy production that something like 16 times more efficient.
Okay, I see the parallel. For years, companies were drowning in data. It was expensive to store, hard to manage, almost toxic because we couldn't really use it effectively.
Precisely. It was this overwhelming flood. Now, companies have to learn to breathe all the data, not just the neat structured stuff in databases, but the other 70, 80, maybe 90%, the unstructured stuff.
Like what? What's unstructured data?
Images, videos, audio files, emails, social media posts, text documents, all those sensor readings from machines.
I got it. The messy stuff.
Yeah. And the tools we have now, running on that Elastic Cloud, things like Hadoop, Spark, MapReduce, they let organizations process absolutely massive amounts, petabytes, exabytes, without having to just take small samples.
So you can see the whole picture almost in real time.
That's the key. That constant flow of all the data is the new high-efficiency oxygen, if your organization can learn to breathe it.
Okay, so cloud provides the power, big data provides the oxygen, the fuel, which naturally leads to the third force, AI and machine learning. How is this different from just, regular software?
The fundamental shift is moving away from humans writing explicit rules for every single possibility. Traditional software is limited by what a programmer can think of beforehand.
Right. If-then statements, basically.
Kind of. AI, and specifically machine learning, learns from the data. It learns from examples, from experience, discovering patterns and making predictions without being explicitly programmed for every step.
And Siebel really emphasizes deep learning, a subfield of ML. He says it tackles this thing called the feature engineering bottleneck. What's that? Why was it a bottleneck?
Okay, so feature engineering was basically the really hard, time-consuming part, where human data scientists had to figure out what signals or features in the data the algorithm should pay attention to.
Like telling the computer exactly what a cat looks like. Pointy ears, whiskers?
Exactly. If you wanted an algorithm to spot, say, a faulty valve in a factory image, you had to tell it, look for this specific shape, this texture, these shadows. It was slow, brittle, and needed tons of expertise.
And deep learning changes that how?
Deep learning algorithms can kind of figure out the important features on their own just by processing millions of examples. They learn the hierarchy of features from simple lines and curves up to complex objects like that valve or a cat. It automates that really hard part.
That makes a huge difference. Okay, so AI learns from the big data fuel powered by the cloud. What's the final piece? The Internet of Things, IoT.
IoT provides the input. It's the network of sensors, devices, machines, all constantly generating and feeding data into the system. It connects the physical world to the digital analysis.
Giving the AI eyes and ears everywhere, basically.
In a sense, yes. It allows for this continuous real-time view of everything, your supply chain, your factory floor, your customer interactions, and the scale is just exploding. Predictions are for 75 billion connected IoT devices by 2025?
75 billion. And the value grows faster than the number of devices, right? There's that law.
Metcalfe's law. Yeah, the value of a network grows exponentially with the number of connections proportional to the square of the nodes. Adding one more device doesn't just add one unit of value, it increases the potential interactions for all the existing devices.
Creating this massive feedback loop. More devices, more data, smarter AI, better insights, driving more changes.
Exactly. It's the convergence of all four that creates this exponential acceleration and the punctuated equilibrium event.
Okay, let's make this concrete. Siebel doesn't just talk theory. He looks at real industries. How does this play out in a heavy capital-intensive business, like, say, energy? He uses Royal Dutch Shell as an example.
Shell is a really good case study, a huge traditional company that's seriously embracing this. They're using AI across their global operations, trying to shift from fixing things after they break to predicting problems before they happen.
Predictive maintenance, right. Give us an example of the scale.
Okay, think about refinery valves. absolutely critical components controlling the flow of liquids and gases. Shell has something like 500,000 of these across their operations.
Wow.
They built an AI application specifically for these valves. It actually runs over 500,000 separate AI models, one for each valve, essentially. It constantly analyzes data from over 10 million sensor signals, pressure, temperature, flow rate, vibration, acoustics.
10 million signals,
Yeah.
feeding 500,000 models.
Yeah, at high frequency. The goal is to predict which specific valves are degrading and likely to fail, so they can prioritize maintenance before a costly or dangerous failure occurs.
That's incredible complexity. What's the payoff? Is it worth it?
Apparently, yes. Siebel estimates that this one application alone generates several $100 million in economic value for Shell every single year.
Hundreds of millions
Yeah.
from just predicting valve failures better.
Right. Fewer shutdowns, lower maintenance costs, safer operations, better efficiency. It shows the prize isn't just incremental improvement, it's massive structural value creation.
But Siebel argues the implications go way beyond just corporate bottom lines. He connects this digital transformation directly to, well, geopolitics and national security.
Absolutely. The stakes get incredibly high very quickly. He quotes Vladimir Putin, who said something like, "Whoever becomes the leader in this sphere, meaning AI, will become the ruler of the world."
That's blunt.
And China has made becoming the world leader in AI by 2030 a core national strategy. So this isn't just companies competing, it's nations positioning for dominance in a new technological era.
Which leads to scary concepts like hyper warfare. What does that actually mean?
Hybrid warfare describes conflict driven by AI, where the speed of action is just too fast for humans. Decisions, attacks, counterattacks happening in seconds or milliseconds, autonomous systems reacting to each other.
That's terrifying. And the risk isn't just theoretical future warfare, right? He mentions infrastructure risks now.
Yes, the vulnerability is real, like the U.S. power grid. Siebel points out that a huge majority of utility executives, something like 3/4, think a major successful cyber attack on critical infrastructure is likely within the next 5 years.
And AI is being used defensively too, right? Like with the F-35 fighter jet program, they were having readiness issues.
Yeah, the F-35's effectiveness depends heavily on its software, its mission data files.
Mm-hmm.
That's the jet's brain, basically, telling it what threats look like, how to react.
Okay.
But updating those files with the latest intelligence analyzing satellite images, reports, videos was this incredibly slow, manual process. It created a huge bottleneck, and the jets weren't always ready or up to date. The mission-capable rate was worryingly low, around 55%.
So how does AI help?
AI is now being used to automate the analysis of all that incoming intelligence data. It can process vast amounts of information way faster than humans, identify new threats, and update the F-35's brain much more quickly, boosting readiness.
Okay, so we've seen the forces, the impact, the high stakes. If you accept Siebel's premise, this is a mass extinction event, speed is paramount, what's the survival plan? What does a CEO, a leader, need to do?
Siebel is adamant about this. It has to be driven from the very top. Leadership, command, from the CEO. This isn't an IT project you delegate down the chain.
Why is that so critical? Leadership's always important, isn't it?
Because, he argues, what's required isn't just adopting new technology, it's fundamentally re-engineering the DNA of the organization. It's an existential threat and opportunity. Trying to do that from mid-level management just won't work. The resistance from the existing structures is too strong. The CEO has to mandate the change.
And it's not just about digitizing what you already do, like swapping paper forms for online forms.
No, that's yesterday's news. That's like putting lipstick on a pig, maybe. Siebel stresses it has to be revolutionary change. You have to fundamentally rethink and reinvent core processes, core structures. Like those organisms switching to oxygen, they didn't just add an oxygen tank, they rebuilt their entire metabolism.
That kind of revolution needs people with totally new skills. But we know there's a huge shortage of AI talent.
It's a massive constraint. The numbers are crazy, like a few big tech giants, Google, Facebook, hiring maybe 80% of the new PhDs in machine learning.
So how does a regular company compete for that talent or build it?
You need the hardcore AI engineers and data scientists, definitely. But Siebel highlights another critical role, the translator.
A translator, what do they translate?
They bridge the gap. They understand the business realities, what the factory manager needs, what the marketing team is trying to achieve, and they understand enough about the AI capabilities to connect the two. They ensure that super smart AI folks are actually solving valuable business problems, not just cool tech challenges.
Makes sense. You need someone who speaks both languages. How do you get these skills if you can't just hire legions of PhDs?
You have to build a culture of intense, continuous learning internally, and you have to incentivize it. Siebel talks about C3.ai's own program. They offer cash bonuses like $1,000 or $1,500, plus recognition for employees who complete tough courses in essential skills like deep learning or natural language processing.
Put your money where your mouth is, basically. Make learning valuable.
Exactly. It signals that these skills are now core, not optional.
Okay, so top leadership, revolutionary change, focus on talent and translation. What about the actual plan? How fast does a CEO need to move in this punctuated era?
The focus has to be relentless speed and measurable economic value. Siebel lays out a benchmark. A large global company should probably aim to get 2 significant, large-scale AI applications into production every 6 months.
2 major AI projects live every 6 months. That's an aggressive pace.
It is, and the rule is, if you can't clearly articulate and measure the expected economic return, the millions in cost savings or new revenue, then don't do the project. Kill it. Focus resources where the value is undeniable. No science projects.
Wow. Okay, this has been quite the deep dive. We've really unpacked Siebel's view. Cloud, big data, AI, IoT converging, triggering this period of intense, rapid change, a corporate mass extinction.
And survival isn't about incremental tweaks. It demands revolution, led from the top, with a huge emphasis on new skills and ruthless focus on value.
The core message seems to be the game has fundamentally changed. Slow, gradual adaptation just won't cut it anymore. The speed is almost geological, like that Cambrian explosion.
That's the takeaway. The environment shifted.
Which leads us perfectly into our final provocative thought for you, the listener. History is full of cautionary tales about dominant companies that just didn't see the disruption coming, or worse, helped enable their own demise.
Think about Borders books.
Yeah.
Back in 2003, they were the leading bookseller, over 1,200 stores. Huge company.
Right, I remember them everywhere.
But in 2001, they made a fateful decision. They outsourced their entire online bookstore operation to Amazon.
Oh, wow. They paid Amazon to run their website.
No. By the time Borders finally realized they needed to get serious about e-commerce and ebooks years later, Amazon was dominant. The game was over. Borders went bankrupt just 1 year after launching its own e-reader.
A classic case of outsourcing your future.
So the final thought for you is this. It's not if your industry is facing this kind of technologically driven disruption, it is. The real question is, what critical knowledge-based part of your business might you be neglecting or even unintentionally outsourcing to the company that could become your Amazon? And critically, are you moving fast enough to rewrite your own ending?